Hi all, let's try to solve this problem n queens. So basically the problem is that we have to place n queens on an end-to-end chessboard and we have to return all possible ways of doing so such that no queens can attack each other. Okay, so suppose we have this. Here we're placing 4 queens on a 4x4 chessboard and there are 2 possible ways to do it such that the queen doesn't attack each other. So let's try to figure out a solution for this. So let's take an initial blank chessboard, okay? And there are multiple ways in which we can place queens, right? Here if you see, you can either place it in the first position, second position, third position, or fourth position. So let's go in an iterative way. So let's do this. I'm placing it here. Next here, next here, next here. Now what I'll do is, again, the next queen, right? I can place it in any of the next. So what I'm going to do is I'm going to recursively call this function and I can place it either here or here or here or here. And I have to place it in a way such that it doesn't attack each other. So if I place it here, it's going to attack with the first queen, right? So this is not a possible way. Here, it's going to attack again. I can place it here, which is going to be here. Next, I'm going to place it here. Okay. And then again, for the next row, I can place it in any 4 ways. This. And every time I place it, I have to see if it's going to attack each other. So here, if I place it here, it's going to attack this row, so it's not possible. If I place here, it's going to attack this, so it's not possible. If I place it here, here, so this is not possible at all. And now suppose we placed our queen here, which is a possible way. We have it here, we have it here. Now I can place it here, which is not possible. Here it is possible, right? It is possible here. So in the next iteration, I'm going to place it here. I have. Next, I'm going to place it here. And in the next iteration, I can place it here. Not possible, not possible, not possible, not possible. So in this way, it's not possible at all. So here we have to do the same thing. So we already placed it in this row. Again, I have to call this function for the next row. So every time I'm going to call a function for every row. So now I'm going to do it for this row and I have to see if there's any possibility of placing a queen. So here it's not safe to place. Here it's not safe. Here it's safe. So it's going to be 4 times, but let me just directly go. Here also it's not safe. Sorry, here it's safe. So let me place it here. So I have a queen placed here. Next I'm going to place it here. In the next iteration, I'm going to pass the next row and I have to see where I can place it. Here it's going to be possible. So here it's going to, I'm going to place a queen here. Here again it won't be possible. Here it won't be possible. Here I won't be. And then final iteration, I'm going to pass it again. And this is a safe position. And once I figure out, and next I'm going to pass next row, and in case the number of the row is greater than equal to n, we can return the actual board structure. So I hope it's a bit clear. So what I'm going to do is I'm going to, one second. Yeah, so every time I'm going to call recursively the same function where I'm going to try to place a queen from 0 to columns, to the maximum of columns, which is going to be n I plus plus. I'm going to try to place a queen in every position, and before placing it I have to check if that particular position is safe. So every time I'm going to call the function, say place queen, and I'm going to pass a row every time. So now I have to check if board of row and I are safe. If it's safe, then I'm going to place the queen in that position. Row comma I is equal to 1, and then after I place it again, I have to I have to recursively call for the next row, right? So again I have to call place queen, and this is going to be for the row plus 1th row, for the next row. So I hope this part is a bit clear. And yeah, once we finish this, at the end we have to backtrack as well. So suppose there's two solutions, then we have to backtrack. For the same queen position here, suppose there are two possible ways. So in order to capture all those two ways, we have to backtrack. So again, we have to set row comma is equal to 0. Got it? Yeah, and if at any position, if a row is greater than equal to n, then let's print solution. Let's return true. Otherwise, at the end, we can return false. Okay, so I think the algo makes sense. So let's try to code it out. We might face a couple of complications while coding. I'm trying the normal backtracking brute force approach, and in case it doesn't work, then we'll think about optimizing. Okay, so let me have my board. Let me have my n. Okay. And now let's call our function. And let's name it solve n queens. Okay, and here we want to pass the first possible way, which is going to be first row, which is going to be 0. Okay, and if there are no possible solutions, we just have to return an empty. So let's add a test case. If n is equal to 2, there's no possible way, right? So what is it returning in this case? Okay, it's expected a empty list. Let's also have our answer list here. Let's have okay, and let's make this a Boolean function. At the end, we just have to return answer, so this need not be Boolean. At the end, we just have to return answer. Okay. Now let's write the function. Okay. Public void solve n queens. Okay. And let me pass the row as well. Okay. So now the first thing to do is, if row is greater than or equal to n, then we know that it's it's a possible solution. So we have to add board to string to answer. Okay, let's just write this function as well. Like just copy this. Okay, now what am I going to do? Answer is basically, for every row it's a list of strings, right? Yeah, so let me okay, now let me iterate through the board. Okay, this is nj++. We know it's an end-to-end matrix. Let's have a string builder. Okay, and if border I comma j is equal to 0, that means it's not a queen. We're going to do sv dot append. We're going to append a dot. Else we're going to, else it is a queen. Q, right? And now we're just going to add it to the sublist. Add. Okay. And finally we just have to add sublist to answer. Okay, so we got the part when it's true. Else. Okay, and now in this case, okay, so this is proper. Let's also return, because at this point it's done and it has to backtrack. Okay, and now for every column we'll have to add a queen if it's safe for that row. For every column is also n, right? I++. And then we have to check if is safe, and here let's pass row comma I. So if it's safe, what we're going to do is we're going to iterate, we're going to recursively call solve nk for the next row, but before that we have to mark the current board as 1. Row comma I, and then we have to iteratively recurse for it. Okay, so we have to solve NQ. Okay, here we're going to pass row plus 1, and after we solve it, after that's done, we have to come and backtrack. So we're setting it back to 0. Okay, not sure if it's going to work, but let's try. And we have to public boolean is safe. Int row comma int column. Okay, so now we have to figure out a logic to determine if a particular row and column is safe. So one thing which we can do is whenever we add something, we have to check if that column has already been filled. Like suppose I'm adding this particular thing, right? If I did it here, it's going to be not safe. So how did I figure that out? If a particular column is already added, and then if I do it here, I also have to check if the left diagonal may anything is present, or if the right diagonal may anything is present. In these 3 conditions, it won't be safe. Column, but only check upwards. Let's try to write the logic for this. Okay, so let me check the column. So for int I is equal to 0, I is less than. Okay, so this is the current column. So from everything till this particular column, I want to check if it's present or not. Till this row, if any column is present or not. So now what I'm going to do is, if board of I comma C, if I find anything is equal to 1, that means it's not safe, so return false. Okay, so we checked the column. Now let's check the upper left diagonal. So for that, for int I is equal to, okay, so I'm at a particular position, and every time I have to keep on checking the left side. So in that way, the row keeps on decreasing and column also keeps on decreasing. Equal to R comma J is equal to C. Okay, and I has to be greater than equal to 0, and J also has to be greater than equal to 0. And then I'm going to do I minus minus in every case, and J minus minus. If board of I comma J is equal to 1, I'm going to return false. Okay, now I have to check the upper diagonal on the right side. So here we have I is equal to r, comma j is equal to c, and now I have to do, so I keeps on decreasing, so I is greater than equal to 0, and j keeps on increasing. J is less than n. J is less than n, and every time I keeps on decreasing, and j keeps on increasing. Okay, so now I have to check if bod of I comma j equal to 1 to turn false. It's not safe, otherwise it's going to be safe. Let's see if this works. Okay, so these 3 test cases are passed. We know that n is to 9 itself, so let me just try a few more. We have 4, 1, 2, 3. So we have 1, 2, 3, 4. Let me try 5. Let me try 6. Let me try 7. Let me try 8. Okay, fine. Okay, and let me try 9. Okay, looks fine. Let's submit. Okay, looks like it passed. Okay, thanks everyone.